Okay, so for part A, the effort here asks to draw an label free body diagram and not the components. So this is the block. There would be f of g, pulling the block down, and f of n acting against f of g. This force of the surface pushing up on the block. This would be f of g plus f of y, since there's a force pushing down in the box. And that would just be this force right here. We'll call F. And since the floor has a coefficient of friction, there would be F of K. For part B, it asks the child to calculate a numerical value for acceleration or slope that could be used. So we know that it starts at rest and it asks to solve acceleration. So x is equal to delta x is equal to VIT plus 1/2 AT squared. There's no initial velocity, so let's just cancel it out. And since we're solving for acceleration, we just isolate. So we just have delta x over t squared is equal to 1/2 a. And the vertical axis would just be x. The horizontal axis would be t squared. And it asks us to fill the remaining empty row, and we would have to fill it with t squared. And we just square each value, and we should get, this is the second squared, 0.2, 0.51, 0.74, 0.90, or 9, and 1.30. So this would go in this row here. For part C, it asks us to draw. It asks us to draw a graph and plot the data points for the quantities in part B. So the time squared. So this would be t squared, which is second squared. This would be x, since the equation we found earlier with rise over run. And let's just say this is 1. This is 2. And if we were to plot these points and the x values, we would get something like this. And the slope would look something like this. For part D, it asks to calculate an experimental value for A. So, no, it's just x over t squared is equal to 1/2 a. So we would get 0.9. But since it's 1/2, if we multiply it by 2, a is just equal to plus 1.8 meters per second squared. For part E, it says using the Newton's second law, derive an expression for the coefficient of friction in terms of F, M, G, and theta, and A. So mu k is equal to Fk over Fn. So this would be in the x-axis, and this would be in the vertical axis. So the net force, the x-axis is equal to ma. And look at this free body diagram and solve. So we know that there's a horizontal component here. So this would just be f of cosine theta minus f of k is equal to ma. But since there's f of k here, we need to isolate for f of k, so it's really just f cosine theta minus ma with f of k. And we need to solve for the vertical axis. So the net force, vertical axis is equal to ma. Since it doesn't move in the vertical axis, it's just equal to 0. And if you look here, this is this component, f of g, and f of n. So just 3 components. So f of n is equal to, or is resisted by f of g plus, no, minus f of g minus f sine theta, since it's the component right here. And this is equal to 0, and we just have to isolate for f of n. So f of n is equal to, this is can be rewritten as mg plus f sine theta, and now we just plug it back into this formula here. Part F, it just gives us values, so we just plug it in to solve for f of k. So we already solved for what f of k is over here, so we just have to plug in values. So it would just be 12 cosine 60 minus 2 is 1.8, and this just gives us 2.4 newtons, and this would be negative because box is accelerating rightward. The force of friction would be resisting it. Part G asks to find the coefficient of friction, and it's just f of k over f of n. So okay, we solve for f of k, which is just 2.4, and we can just use the magnitude because the coefficient of friction doesn't have any direction. This would just be 2. And this would just equal 0.08. H asks if the applied angle decreased, what effect would it have on acceleration? So, it only accelerates in the x direction. So, we can just look at the net force in the x direction. And this would just be the force pushing the box, which is F cosine theta, minus F of k equals ma. But we need to isolate for F of k. So uk equals F k over an F of n. So this is F cosine theta minus uk times F of n. But we can break F of n down. And we solved for F of n earlier, which is right here. So we just plug that in. So what we really have is mu k times mg plus F sine theta. So let's see, ma. And if theta decreases, then F cosine would increase and F of sine would decrease. So what that means is the force in the horizontal direction increases while the vertical decreases. So that means that there would be less friction, since as more weight is pushed down, then there'd be more friction. So A would increase. For part I, it asks to draw a graph for acceleration. So this would be acceleration, which is just meters per second squared. This would be time, which is just seconds. And let's say this is 2, 1, 1, 2. The slope would look something like this. And this lines up with our statement earlier that is 1.8 meters per second squared. The velocity graph for part J should be meters per second, time in seconds. It's 2, or still this 4, 3, 2, 1. This slope should be around 1.8. For part K, it asks to draw a xt graph. Should be x meters and t seconds. So in the first second, we'll just cover 1 meter. It would look something like this.